All right, rational functions. So before we actually graph them, let me show you what they're going to look like. We're going to do easy ones today. We'll get a little harder tomorrow. Today, they're going to look something like, what do you think the dashed lines are?
Asymptotes.
Asymptotes. Not necessarily the axes. They're going to look something like this. Yes. Rational functions, if you think about rational numbers, this is where the variable appears in the bottom as a fraction, okay? And so some kind of crazy things start happening when we start graphing that. We have a lot of restrictions in the domain. We have some range restrictions. So these are just the simple ones, though. It's going to look like that, or maybe they'll be inverted. Maybe it'll look like this. I'm basically leaving one number out of the domain and one number out of the range here. Hence my horizontal and vertical asymptotes. So on your flow chart, the first question I ask you is, does x have an x in the denominator, in the top or bottom of the fraction? That should say, oh, an exponent. I'm sorry. Does x have an exponent? So let's say I'm graphing, and we'll just do the parent function first, 1 over x. Okay. Do you see an exponent in the top or the bottom? No. No, this is your reference sheet. No. So do you know how to read a diagram like this?
No.
I look at the answer that says no, and I follow that arrow. So what's the next question say?
Does x appear in the top and bottom of the fraction?
No. So which square? It's on the bottom. It's not top and bottom. It's only in the bottom. So I'm in the middle rectangle. Does everybody see where I am? The one that had that little question mark that I told you to change to an H? Okay. So step one. This is basically a step sheet for every form of rational function you'll get. Okay. The first step says, find and graph the horizontal asymptotes, and then it says y equals k. So my horizontal asymptotes are y equals k. Well, if you look at the original equation that we're referencing, it's a over x minus h plus k. Excuse me. So in this one, what is the horizontal asymptote? 0. So my horizontal asymptote here is y equals 0.
Why is it 0?
Because that's k. Your k on the end is your horizontal asymptote. And since there's not one here, it's 0. Horizontal goes across. Does that make sense so far? Step 2. Find and graph all vertical asymptotes. Horizontal asymptotes. And then it says, to do that, set the denominator equal to 0. And if you think about it, this makes sense. The bottom of a fraction can never be 0, right? So there's a hole in my graph there. That's where I can't have x equals 0, which is the bottom of this. So my my vertical asymptote is at 0. X can never be 0 because it would cause me to have the 0 in the bottom of the fraction. Does that make sense? All right, look. Set denominator equal to 0 and solve for x. That is your vertical asymptote. I set the denominator equal to 0.
1 divided by 0 is 0.
And it's already solved for x. There's nothing else in there. So 0 is my horizontal asymptote. Does that make sense? Then the last thing is to make a t-chart. This is where your calculator is your friend, especially with these rational functions. Now, if you don't have a graphing calculator, you're going to have to do this by hand. I'm sorry. Shamik, that's mine. Easiest way to come up with these points. My equation, and if you read on your sheet, it says to pick 2 points on either side of the asymptote, the vertical asymptote. So what I want to do, if you go into your y equals and type your equation.
1 divided by x.
Okay.
Go over the table.
If you go into the table, you should be, if you hit second graph, you should be able to see, and we can set this up actually, and let's go ahead and set it up now. If you're here, if you go into second table set, which is window, second window, change this from auto to ask.
I already have it in
Okay.
Are you
there.
cool?
And then the table set
Enter.
can always be -3.
And go back into your table. That's going to allow me to input the numbers that I want. Because remember, I want on either side of this asymptote. So I want -1, -2, 1, and 2. Yeah.
We put after independent.
Yes, because that's your X. You want to be able to ask your X.
So why do you have ones?
Because I want to input negative, and this is an easy one to do without the calculator, but we're fixing to get in some really nasty ones. -2, -1, 1, and 2, because you want 2 points on either side of every vertical asymptote. Okay?
So, but that's not what mine shows.
Your table should automatically let you just type in the numbers, does it not?
Mine, mine
Okay.
goes like this.
That's fine. You're not on ask, you're on auto. Okay, hit back in your table. Now type the number you want,
What do you mean?
That's what give.
and it gives you that value.
That's what give.
Well, 0 is an asymptote, yes.
So then what do I put in?
In this T-chart, I want to look at my asymptote, and I want to go 2 to the left, so that would be -2 and -1, and I want to go 2 to the right, which is 1 and 2. So I used my calculator.
-2 is -0.5.
To figure out those points, okay? So -1/2
You always use this number?
and -1. If that's your asymptote, yes. 1 and 1/2. Okay, you didn't for that. This one was easy, but we're fixing to get into some really difficult ones that you would be here. And if you imagine if you have more than one vertical asymptote and you have to pick 2 on the left and 2 on the right, well, 2 asymptotes would mean you'd need 2, 4, 6, 8 different points. All right, so all that's left here is to graph. -2, -1/2, -1, -1, 1, 1, and 2, 1/2. Remember what asymptotes do? They're boundaries here. Does that make sense? It's really easy with the step chart. I probably should make you learn it without the step chart, but
That's on at the very bottom. That's a point.
that was just an arrow saying point now. What's the domain here? Domain is X. Yes. Is it? So X can be anything in the whole wide world? It can't be what? 0. So I can get up as close as I can to 0, but I can't actually touch it. And then I pick back up with 0, and then I can go as big as I want.
What is you?
Y'all don't remember this?
Remember what?
U is a union. It joins 2 pieces together. So if we jumped, and I'm going to come back to that. Let's say, actually, let's do this. Let's say I had this and this. And this point was 0, 2, and this point was 0, -1. and I want to talk about the range, well, there's some things left out right there. Negative infinity, because you always start with the smallest. So negative infinity up to, what does it stop? -1. But that's not all of the range, right? There's another piece of the range there that I need to pick up. This is a bracket because that point is on -1. I need to combine that with this piece of the range, which picks back up at 2 and then goes up forever. It just allows you to join.
So does the one that's on the bottom part of the graph go first?
You always start with the smallest up to the biggest. What is that beeping? Do y'all hear that?
It's the bottom.
It did stop. All right, so now back to this one. Not that yellow line. But this one, what's the range here? What's the lowest the graph ever goes? Negative infinity. Then it goes up to 0. Does it touch 0?
No.
No. But then it picks back up on the other side of 0, so I union that and up to infinity. You don't remember learning union and intersection?
Union.
I don't know
Yeah.
about everybody union in the
Yeah,
sense.
yeah.
Exactly.
What?
I call it computers.
Let's see if I can figure out how to.
All right, let's do another one.
Remember when I found the lighter on the ground?
Yes. All right. I'm looking at my flow chart and I'm wondering which rectangle should I be in? The first one, the middle one, or the last one?
Wait.
Well, the
middle.
the something is on the
Middle.
very
The
end.
middle one. There's no exponent. And x is only in the bottom. It's not in the top and bottom. So I'm ready to go. I'm going to follow the same steps. So step 1, I need to find my horizontal asymptotes, which are y equals k. What is k?
K equals -1.
-1. So y equals -1. Oh, I have shifted.
Wait, we're doing regular lines now?
-1. That's my axis. There's my asymptote. Yes?
Yeah.
Step 2. Find and graph all vertical asymptotes. To do that, I set the denominator equal to 0. If x plus 2 equals 0, what does x equal? -2. Is anybody confused at this point? My vahs and haws.
Vertical asymptote.
Oh,
Two asymptotes.
And then when you put it into
Now my question to you is,
I love this graph.
what points do I need to pick for my T-chart?
All of them.
the same one we did last time. Not me.
Here's my asymptote. I need 2 on either side.
Then you like.
Man, the wind keep blowing my tape.
So which ones? Which ones did you pick? -3,
-4,
-4,
-2. I mean, no, not -2. -1 and 0.
If I put insert, it even puts a 0 for me.
All right, I got to change up here.
And we get second graph.
Be careful when you're putting in, yes, be careful when you are putting in equations, especially with fractions.
So what
Fractions
if I
go
put
in parentheses, and whenever the denominator or the numerator have multiple parts, you really want to put those in parentheses also.
Can you let me borrow your calculator?
Oh, I forgot the negative. Yes, ma'am.
How did you get
What we put in the calculator?
I'll look at the top of
I looked at the asymptote and I went 2 to the left and 2 to the right of the asymptote. The green asymptote.
it. Equal on top of the flat top.
That's what she just asked. If you look at the green asymptote that's up and down, guys, y'all pay attention so I don't have to answer the same question a bunch of times. Look at the vertical asymptote here. Okay? Go 2 to the left, so 1, 2, and go 2 to the right. 1, 2. Now what are those points? Those are -4, -3, -1, and 0. So I've got my equation ready to go. I'm going to second.
Wow.
Second table.
Error.
-3. By the way, why is it all of a sudden saying an error at -2?
Because -2 is the asymptote.
That's my
Why
asymptote.
does it
That's
say
right.
error? Oh. Never mind.
It's much harder to try to input it to that.
It's harder?
To input it to by your computer.
Oh, with my computer, yeah. All right, so I have 3. 1, -5, and -3. -3. 1, 2, 3.
-3. 3, little band.
What is that number for -3?
-4, 1.
Yeah, 3.
They're basically like a barrier for each other.
Ah, I didn't do that. It's -1.
5. Then 0.
I don't want to leave anybody. Yes.
When I plugged in -4 for X, my chart didn't say Y is -3.
I'm imagining you probably input something incorrectly in your y equals.
Oh my goodness.
Your calculator is stupid, dude.
If you hit graph while you're here, you can also see what it's supposed to look like.
Oh,
Oh, that's what mine
why does
did.
yours do that?
Mine graphs vertical asymptotes, but not horizontal for some reason.
How does it show that?
Some of them just do. So you have to be able to correctly interpret what's a part of the graph.
Let me show you on my calculator.
It's okay, you know it's
My
there.
graph looks like a man.
That's all we're doing.
What's the domain? Yes.
How do you put in the horizontal?
Horizontal is the K that's on the end here.
Okay.
You probably, oh, excuse me, did not input the correct equation. There's what it should look like. Look at mine.
The lowest it can be is negative.
You got to put parentheses around that denominator. Horizontal is the K on the end. Vertical is the denominator equal to 0. Correct. Here. What is the domain on this function? Negative infinity to,
-1.
where's your asymptote?
-1.
-2.
Why is it -2?
Domain is left to right. And then you pick back up -2 to infinity. I'm sorry about that.
Domain left to right.
Range, Juliana, is your negative infinity up to -1. Range is up and down. Domain is left to right.
Is it still -1 even though it doesn't reach to -1? For
That's why we got a parenthesis and not a bracket.
I like this.
But it doesn't reach to
It's better than
-1.
last
Top
This is
one.
the
one.
first time in weeks I've actually liked something.
Oh,
Tomorrow's
wow.
graphs are going to get funky.
I'm focused on today.
It's easy when you've got a step sheet printed out for you like this. It makes it a lot easier. When you get to pre-cal next year, you won't get a step sheet. So
What did you take, regular pre-cal?
yeah.
Yeah, let's see.
They could look. There's not a general form. Some of them will just look like this. Some of them will look like this.
Oh.
Some of them
That's so pretty.
What is this?
will look like this. I think that's most of the general.
What's the ugly one?
All right, let's do one more. What is it? That's tomorrow. All right. Absolutely, that's what we're fixing to do. 2x plus 1 over x minus 3. I'm in a different
Box one.
rectangle. I'm in box 1 now. Absolutely. So show me, what's my first step in box 1?
Find the graph horizontal asymptotes.
But this time it's different.
So 2 over x,
What's the leading coefficient at the bottom?
1.
1. So x equals
2.
Wait, 100%?
leading coefficient of the top divided by leading coefficient of the bottom.
Okay.
I'm on step 1.
And then y.
And that should actually be y equals. I can't
Y
believe I
equals
just did that.
Maybe it's the right angle.
That's my horizontal. Y equals. That's why I changed it to y equals. 2.
Will the graph look the same?
The simple ones, yes. Step 2 is the same as step 2 in the other. Denominator to 0 for my vase. Vase.
Denominator 0.
How do you find what, Sierra? It's the ratio of the leading coefficients, so 2 divided by 1. That's written on your step sheet too. We're in the first box,
Wait. So it's 3.
so it's 3.
This graph's going to look really weird.
All right. XY. What x's should I pick? Dun, dun, dun.
How can you tell?
How can you tell?
Okay, so you want to pick.
Read the, wait just a second. Shamik. Step 3, read it for me real quick. And then Tanner, I'll let you tell me.
Make a T-chart to plot points. Choose at least 2 points on either side of the vertical asymptotes.
Okay, so Tanner, which ones do you think we should pick?
Or would you choose these 2 sides?
You just have to have enough to pick up the pattern. You know they're going to hug asymptotes. That's their boundaries there. 1, what else?
2.
2, what else?
4.
What else?
5. I'm
1, 2, 4, 5. What did you say?
He said I'm 10.
What did I call you? Did I call you Tyler again? Oh.
I'm not kidding you. This is 1, 2, 3. So 1, 2, 4, 5. Oh.
Y equals. Now, if you want to come off to the side and plug all these numbers in and sit here and go, okay, if I plug in 2, then I get 2 times 1 plus 1 over 1 minus 3, which is 3 over negative 2, which is negative 1.5. Me personally, I just soon plug it in here. And I want to go parentheses, 2x plus 1.
I like this one. It looks very good.
Divided by
Wait, why'd you get -1.5?
I was just plugging it in myself. If I go into my table though, 1, 2, I was just showing you how long it would take to plug in each individual point.
I got it all.
4 and 5.
1.
-5, 9. What was that last one? 5.5, thank you. So 1, -1.5, 2, -5, 4, way up here at 9, and 5 is at 5.5.
This is somewhere up here.
That's what I
That's not even
see.
existing.
I didn't plan my graph well.
You got homework tonight?
Domain, what's the domain?
Left to right, it's not.
-2, 3, union.
Was. Oh, yeah.
There's no gap there. It hugs the asymptote from both sides. How about the range?
Range is up and down.
Okay, I got this one. I got it.
So
I'll
range
say
is negative infinity and 2, and then 2 and infinity.
The domain, the vertical asymptote impacts the domain. The horizontal asymptote, it's the
So
range
vertical,
that's impacted.
so vertical is for domain,